There's a spacecraft right now sending back photographs from a place so dark that our sun is just another dim star, and what it's seeing is rewriting everything we thought we knew about the universe. New Horizons has traveled farther into the cosmic void than any camera-equipped spacecraft in history. It's beyond Pluto, beyond the Kuiper Belt, beyond the reach of our sun's warmth. And from that impossible darkness, it's photographing stars, galaxies, and cosmic mysteries that look completely different than they do from Earth. By the end of this video, you'll discover why NASA scientists are saying these images represent the most accurate view of reality humans have ever captured, and why what they're finding in the darkness is forcing us to question measurements we've trusted for decades. Let's start with where New Horizons actually is right now. On January 19, 2006, NASA launched a piano-sized spacecraft on the fastest mission ever attempted. Its target, Pluto, a world nobody had ever seen up close. The journey took 9.5 years. In July 2015, New Horizons screamed past Pluto at over 31,000 miles per hour, capturing images that revealed a world far more complex and beautiful than anyone imagined. But here's the thing. NASA didn't build a spacecraft capable of surviving a 5 billion mile journey just to snap a few photos and quit. So they kept going. Past Pluto, past the icy object Arakoth, into the outer solar system's eternal twilight. Today, New Horizons is more than 5.3 billion miles from Earth. That's 57 times farther from the Sun than we are, and from out there, everything looks different. Here's what most people don't realize about space photography. When you take a picture of the night sky from Earth, or even from orbit, you're not just capturing starlight, you're also capturing scattered sunlight, reflected moonlight, airglow from the atmosphere, and something called zodiacal light. Zodiacal light is sunlight reflecting off millions of dust particles floating in the inner solar system. It creates a faint glow across the entire sky, even in the darkest locations on Earth. Think about it. It's like trying to see distant city lights while standing next to a campfire. The nearby light source overwhelms your vision. But New Horizons, it's moved away from the campfire. Out where New Horizons is now, sunlight is 900 times dimmer than on Earth. The zodiacal light has dropped to nearly undetectable levels. There's no atmosphere, no moon, no nearby planets reflecting light back. The spacecraft is swimming in the darkest sky any human-made instrument has ever experienced. And in that darkness, it can see things we've never been able to see before. From Earth, every star you see in the night sky is lying to you. Not about its existence, but about its exact position in space. Here's why. The Sun is so massive and so close to us that its gravity bends space-time around it. When light from distant stars passes near the Sun on its way to Earth, that curved space-time bends the light's path. Einstein predicted this in his theory of general relativity back in 1915. Scientists confirmed it during a solar eclipse in 1919 by measuring how stars near the Sun appeared to shift position. Get this, even stars that seem far from the Sun in our sky are affected. The Sun's gravitational influence extends throughout the solar system, subtly warping the apparent positions of every star we observe. We've known about this for over a century, but we've never been able to escape it, until now. New Horizons is so far from the Sun that its gravitational lensing effect is minimal. For the first time, we're seeing stellar positions that aren't significantly warped by our star's mass. The truth is, NASA is using these measurements to create what they call pristine parallax maps, the most accurate three-dimensional chart of our stellar neighborhood ever produced. Astronomers are comparing New Horizons measurements with observations from Earth and finding tiny but significant differences. Stars we thought were in one position are actually in slightly different locations. What does this mean? Every distance calculation, every velocity measurement, every model of stellar motion we've built, all of it is being refined with unprecedented accuracy. In that perfect cosmic darkness, New Horizons discovered something that has scientists completely baffled. The universe has too much light. Let me explain what I mean by that. Astronomers have spent decades cataloging galaxies, They've counted hundreds of billions of them, measured their brightness, calculated how much light they produce. They've done the math, accounting for every known light source in the cosmos. Then they added it all up to predict how bright the cosmic background should be, the faint glow you'd see if you looked at empty space, away from any individual star or galaxy. New Horizons measured that background glow, and the numbers don't match. There's excess light. A lot of it. Roughly twice as much as all the known galaxies can account for. Scientists were shocked to discover this discrepancy, because if our galaxy counts are right, this light has to be coming from somewhere else. But where? Here's the thing. There are a few competing theories, and all of them are mind-blowing. Maybe there are hundreds of billions of dwarf galaxies out there, tiny dim collections of stars that are too faint for even our best telescopes to detect from Earth. New Horizons might be seeing their combined glow. If this is true, the universe contains far more galaxies than we've ever imagined. This one's even stranger. When galaxies collide, which happens more often than you'd think, stars get ripped away from their homes and flung into intergalactic space. These orphan stars don't belong to any galaxy. They drift alone in the darkness between galaxies, invisible to us as individual points of light, but collectively creating a faint glow. Think about it. Entire populations of homeless stars, wandering the cosmic void, their light blending into a diffuse background we can only now detect. And then there's the possibility that excites and terrifies scientists in equal measure. Maybe we're seeing light from something we don't understand yet, an unknown population of objects, a new type of cosmic structure, something lurking in the darkness that we haven't even theorized about. The truth is, New Horizons has raised more questions than it's answered, and scientists are racing to figure out which explanation is correct, or if it's some combination of all three. Here's what nobody talks about when they discuss New Horizons' extended mission. NASA isn't just using it to discover new things, they're using it to check if everything we thought we knew was actually correct. Astronomers call New Horizons a cosmic optical bench, a reference standard floating in the purest darkness humanity has ever accessed. Think about every astronomical measurement ever made from Earth: brightness of galaxies, colors of stars, distances to nebulae. All of it had to be corrected for interference, atmospheric blurring, zodiacal light scatter, instrumental noise, light pollution from human sources. Scientists have gotten really good at accounting for these factors, but really good and perfect aren't the same thing. New Horizons operates in an environment with almost none of that interference. When it measures how bright a star is, that measurement is as pure as physics allows. Now, NASA is comparing New Horizons measurements with observations from Hubble, James Webb, and ground-based telescopes, and they're finding discrepancies. Not huge ones, we're talking about a few percent in most cases. But in astronomy, a few percent can be the difference between a correct model and a completely wrong one. Some stars we thought were one brightness are actually slightly different. Some galaxies we classified as one distance might be closer or farther than we believed. Get this, we're literally recalibrating the universe. Every standard candle we use to measure cosmic distances, Cepheid variables, type Ia supernovae, the cosmic microwave background, all of them are being cross-checked against New Horizons' pristine observations. This matters because astronomy is built on a ladder of measurements. We use nearby objects to calibrate our understanding of medium-distance objects, which we then use to understand far-away objects. If the bottom rungs of that ladder are even slightly wrong, errors compound. By the time you're measuring the edge of the observable universe, small mistakes become massive miscalculations. But here's the catch. New Horizons can only measure what's in its field of view. It's one spacecraft, in one location, looking at one part of the sky at a time. To truly recalibrate our cosmic measurements, we need more data, more observations, more time. Which brings us to a problem that's more urgent than most people realize. New Horizons is running out of time. The spacecraft doesn't run on solar panels. It's too far from the sun for that to work. Instead, It's powered by a plutonium battery called a radioisotope thermoelectric generator, or RTG. Inside this device, plutonium-238 naturally decays, producing heat. That heat is converted into electricity, about 200 watts when the mission launched. Here's the thing. Radioactive decay never stops, but it does slow down. Every year, New Horizons loses about 4 watts of power. That might not sound like much, but when your entire spacecraft runs on less electricity than 3 old-fashioned light bulbs, every watt is precious. Right now, New Horizons is down to about 180 watts. The spacecraft uses that power for everything: computers, transmitters, instruments, heaters, to keep electronics from freezing in the 400 degrees environment of deep space. NASA estimates they'll have to start shutting down instruments around 2030. By the mid-2030s, there won't be enough power to run the transmitter. Most people don't realize this, but New Horizons will probably go silent in our lifetime, within the next 10 to 15 years. After that, it'll still be out there, still traveling through the darkness at 31,000 miles per hour, but it won't be able to talk to us anymore. It'll become a silent ambassador carrying a message for any intelligence that might find it millions of years from now. Because yes, New Horizons carries a tribute to humanity, just like the Voyager spacecraft do. But before it goes silent, NASA is planning something extraordinary. But here's what they didn't tell you in the press releases. New Horizons isn't just taking pictures anymore. It's about to become one half of the most ambitious astronomical experiment ever attempted. In 2025, just next year, New Horizons will photograph the same nearby stars that Voyager 1 is looking at from the opposite side of the solar system. Think about it. 2 spacecraft separated by over 11 billion miles, taking pictures of the same stars at the same time. Why does this matter? I'll explain in a moment. But first, you need to understand just how far apart these 2 machines actually are. The distance between Voyager 1 and New Horizons is greater than the diameter of our entire solar system. It's 60 times wider than Earth's orbit around the Sun. And from those 2 vantage points, stars look different. Not a lot different. We're talking about tiny angular shifts measured in milliarc seconds, but those tiny shifts contain revolutionary information. Before New Horizons entered the cosmic darkness beyond, it had to pass through the Kuiper Belt, a vast ring of icy objects beyond Neptune. We thought we understood this region. We were wrong. For decades, astronomers believed the Kuiper Belt was relatively uniform, a scattered collection of frozen debris left over from the solar system's formation. New Horizons flew through it and discovered something unexpected: structure. The Kuiper Belt isn't random. There are patterns, clusters, gaps, gravitational influences from objects we haven't discovered yet. In 2019, New Horizons flew past an object called Arrokoth, a strange snowman-shaped world made of 2 lobes gently stuck together. Scientists were shocked to discover how pristine it was. Arrokoth formed 4.5 billion years ago and has barely changed since. It's like a frozen time capsule from the solar system's birth. But here's where it gets crazy. Arrokoth's shape and composition tell us it formed slowly and gently, not through violent collisions. That contradicts a lot of our models about how the outer solar system came together, and Arrokoth isn't alone. New Horizons instruments detected thousands of other objects in the Kuiper Belt, most too small and distant to photograph, but detectable through reflected sunlight and thermal emissions. The data suggests there are far more objects out there than we predicted, and their distribution isn't random. There are gravitational shepherds organizing them. What does this mean? There might be undiscovered worlds in the outer solar system. Not Planet 9 necessarily, but significant objects, mini-planets perhaps, influencing the Kuiper Belt structure. New Horizons is still collecting this data as it flies farther out. Every month, it samples a new region of space, building a 3-dimensional map of the outer solar system that no Earth-based telescope could ever create. But the Kuiper Belt is behind it now. Ahead lies something even more mysterious. New Horizons is approaching a boundary that most people have never heard of, but it's one of the most important invisible lines in the solar system. It's called the heliopause. Here's the thing. Our sun doesn't just emit light, it emits a constant stream of charged particles called the solar wind, protons and electrons blasting outward at 1,000,000 miles per hour. This solar wind creates a bubble around our solar system, pushing back against the interstellar medium, the gas and dust between stars. The heliopause is where these two forces balance. It's where the sun's influence ends and true interstellar space begins. Voyager 1 crossed it in 2012. Voyager 2 crossed it in 2018. Both spacecraft detected dramatic changes in their environment. The solar wind dropped to zero, cosmic rays from deep space increased, and the plasma density jumped. New Horizons will cross the heliopause sometime in the 2040s or 2050s. We can't predict exactly when because the boundary moves in and out like a breathing lung, responding to solar activity. But here's what makes New Horizons crossing special. It will approach from a different angle than the Voyagers did. Think about it. The Voyagers went out in one direction. New Horizons is heading out in a completely different direction, about 60 degrees away in sky coordinates. When New Horizons crosses the heliopause, it'll tell us whether that boundary is roughly spherical, like most models predict, or weirdly shaped. It'll measure whether the transition is sharp or gradual in that direction of space. Most people don't realize this, but we're using these spacecraft to map the three-dimensional shape of our solar system's protective bubble. And depending on what New Horizons finds, we might discover that our cosmic neighborhood is far stranger than we ever imagined. As New Horizons travels toward the heliopause, its instruments are detecting something Voyager saw hints of but couldn't fully measure: a wall of hydrogen at the edge of the solar system. Here's what's happening. Interstellar space isn't empty. It's filled with extremely thin gas, mostly hydrogen atoms, about 1 per cubic centimeter. When the solar wind pushes outward and hits this interstellar medium, it compresses the hydrogen into a denser region just beyond the heliopause. Scientists call it the hydrogen wall. New Horizons has a UV spectrometer that can detect this hydrogen by measuring how it absorbs a specific wavelength of ultraviolet light called Lyman alpha. The spacecraft has been watching this signal get stronger as it approaches the boundary, and the measurements are revealing something unexpected. The hydrogen wall is lumpier than predicted. There are regions where it's denser and regions where it's thinner. This suggests the interstellar medium itself has structure. It's not uniformly distributed. Get this. Those lumps might be telling us about ancient supernova explosions. When a massive star explodes, it blasts gas outward in an expanding shell. Those shells can persist for millions of years, creating regions of higher or lower density in the interstellar medium. New Horizons might be detecting the edges of ancient supernova remnants that our solar system is currently passing through. The truth is, we're not just studying our solar system's edge, we're studying the galaxy's local environment, the neighborhood our sun is traveling through as it orbits the Milky Way, and that neighborhood is far more dynamic and complex than we ever suspected. But here's the catch. All of these measurements depend on New Horizons staying functional, which brings us back to the ticking clock. Now, the most important thing New Horizons will ever do. It's called the Interstellar Parallax Experiment, and it's happening right now. Remember how I mentioned New Horizons and Voyager 1 are going to photograph the same stars from different positions? This is where that becomes revolutionary. Parallax is the apparent shift in position of a nearby object when you view it from different locations. Hold your finger up at arm's length and look at it with one eye closed, then the other. Your finger appears to jump against the background. That's parallax. Astronomers use parallax to measure distances in space. The more distant something is, the less it appears to shift when viewed from different positions. For over a century, the best parallax measurements came from Earth's orbit. We photograph a star in January, then photograph it again in July when Earth is on the opposite side of the Sun, 186 million miles away. That 186 million mile baseline lets us measure distances to stars up to a few thousand light years away with decent accuracy. But New Horizons and Voyager 1, they're 11 billion miles apart. That's 60 times better than Earth's orbital baseline. Think about it. We're creating a parallax measurement system that spans a distance wider than our entire planetary system. Scientists are calling it interstellar stereoscopy, true three-dimensional vision of the cosmos. When these two spacecraft photograph the same nearby stars, the angular shifts they measure will be enormous compared to Earth-based measurements. Stars that appear to shift by milliarc seconds from Earth's orbit will shift by entire arcseconds when viewed from this massive baseline. What does this mean in practice? We'll be able to measure distances to nearby stars with unprecedented precision. Stars within 30 or 40 light-years, our immediate stellar neighborhood, will have their distances measured to within a fraction of a percent accuracy. But here's where it gets crazy. Accurate distances lead to accurate brightnesses, and accurate brightnesses lead to accurate stellar classifications. Scientists will be able to determine the true luminosity, size, mass, and age of nearby stars with precision we've never had before. And this is the part that changes everything. Some of those stars are used as calibration standards for measuring distances to farther objects. Remember that cosmic distance ladder I mentioned? The bottom rungs are being rebuilt with New Horizons data. Cepheid variable stars, pulsating stars that we use to measure distances to nearby galaxies, are calibrated against nearby parallax measurements. If those parallax measurements are off by even a small amount, our distance calculations to galaxies could be wrong by millions of light-years. Type Ia supernovae, the standard candles we use to measure the expansion of the universe, are calibrated against Cepheids. If Cepheid distances are wrong, supernova distances are wrong, and if supernova distances are wrong, our measurements of the universe's expansion rate, the Hubble constant, could be significantly incorrect. The truth is, the New Horizons parallax experiment might resolve one of the biggest mysteries in modern cosmology. Right now, there's a crisis in physics. Two different methods of measuring the Hubble constant give two different answers, and nobody knows why. Method 1 uses the cosmic microwave background, light from the early universe. It gives a value of about 67 kilometers per second per megaparsec. Method 2 uses Cepheids and supernovae, the cosmic distance ladder. It gives a value of about 73 kilometers per second per megaparsec. That's a 9% difference. It sounds small, but in cosmology it's enormous. These measurements should agree. The fact that they don't mean something is fundamentally wrong with our understanding. Either our measurements are flawed, or the universe is more complex than our models predict. New Horizons parallax data might tell us which one it is. If the spacecraft-based measurements confirm the Cepheid supernova method, it means the cosmic microwave background method needs revision, or our understanding of the early universe is incomplete. If New Horizons data suggests we've been measuring Cepheid distances wrong, it could reconcile the two methods and preserve our current cosmological model. Either way, we're on the verge of a breakthrough that will reshape our understanding of the universe's past, present, and future. And it's all happening because a spacecraft the size of a piano is floating in the darkness, 5.3 billion miles from home, taking pictures of stars. So what does all of this mean for the future of space exploration? Here's the thing. New Horizons has proven something that will change how we design missions for the next century. Extended missions work. Look at the numbers. New Horizons' primary mission to Pluto cost about $720 million and lasted 9 years. The extended mission, everything since the Pluto flyby, has cost a tiny fraction of that. Maybe $50 million total, spread over nearly a decade of additional science. For that modest investment, we've gotten the Arakoth flyby, the cosmic optical bench calibrations, Kuiper Belt mapping, interstellar parallax measurements, and observations of the heliosphere's edge. Think about it. The return on investment is staggering. NASA is taking notes, so are the European Space Agency, the Japanese Space Agency, and private space companies. Right now, there are proposals for dedicated interstellar missions, spacecraft designed from day one to leave the solar system and study the nearby galaxy. One concept, called the Interstellar Probe, would travel 1,000 times farther than New Horizons over 50 years. It would carry advanced instruments specifically designed to study the interstellar medium, nearby star systems, and the galaxy structure from outside the Sun's influence. From that distance, about 1,000 astronomical units from the Sun, our entire solar system would fit inside a circle smaller than a full moon in the sky. Imagine photographing our solar system from the outside. Seeing Earth and Venus and Mars as pale dots, barely distinguishable from each other, all clustered around an ordinary star. That perspective shift would be as profound as the pale blue dot image Voyager 1 sent back, but magnified 1,000 times. But wait, there's more. New Horizons is also inspiring a different kind of mission. Scientists are proposing something called a solar gravitational lens telescope. Here's how it would work. Einstein's general relativity tells us that massive objects bend light. The Sun is massive enough that it can act as a gravitational lens, focusing light from distant objects. There's a point about 550 astronomical units from the Sun, roughly 3 times farther than New Horizons is now, where the Sun's gravity focuses light from objects directly behind it. If you placed a telescope at that focal point, you could use the Sun itself as a lens to magnify distant objects. Get this. The magnification would be so powerful that we could potentially image exoplanets in detail, not just detect them, but actually see their surfaces, their clouds, maybe even signs of continents and oceans. NASA is seriously studying how to send a mission to that focal point. It would take decades to get there, but the payoff would be transformative. We could study potentially habitable worlds in ways that no Earth-based or space telescope could ever achieve. And none of this would be on the drawing board if New Horizons hadn't shown us what's possible when you send a spacecraft into the darkness and keep it running. Most people don't realize this, but the space age is still in its infancy. We've barely stuck our toes into the cosmic ocean. New Horizons is one of only 5 spacecraft ever to reach escape velocity from the solar system, the others being Pioneer 10 and 11 and Voyager 1 and 2. 5 machines out of thousands launched that will travel between the stars forever. Each one is carrying a message from humanity, plaques, golden records, tributes to those who built them. In New Horizons' case, it carries some of the ashes of Clyde Tombaugh, the astronomer who discovered Pluto in 1930. Tombaugh spent his life dreaming of what Pluto looked like. He died in 1997, never knowing. Now part of him is traveling past Pluto, into the darkness beyond, aboard the spacecraft that finally revealed his distant world. Think about it. Millions of years from now, when our civilization is long gone, when Earth itself might be unrecognizable, New Horizons will still be out there, drifting between stars, a silent testament to a species that looked up at the darkness and decided to reach into it. New Horizons is still transmitting right now as you watch this video, traveling at 31,000 miles per hour, every second taking it 8.6 miles farther from home. Its radio signal takes over 7 hours to reach Earth. When scientists send a command, they have to wait 14 hours for a confirmation that it worked, and yet across that impossible distance, data flows. Images arrive, measurements accumulate. Every day we learn something new about the darkness. Somewhere out there, in a darkness deeper than any human has ever experienced, a machine we built is showing us the universe as it truly is. The only question is, are you paying attention to what it's teaching us?